Hi, this is Fred Wang from University of Tennessee, Knoxville. Today I'm going to give an overview on our Power America projects for the last 3 years. The project title is Multifunctional, High Efficiency, High Density, Medium Voltage Silicon Carbide Based Asynchronous Microgrid Power Conditioning System Module. This bottom picture shows a schematic of the PCS module with its controller. It serves as an interface between the microgrid on the right hand side and the distribution grid on the left hand side. The key metrics for our development is the PCS module will be using 10 KV silicon carbide MOSFET switching at greater than 10 kHz to deliver at least 100 kVA power at 13.8 kV voltage, achieving efficiency as well as density target, and also have sufficient control bandwidth for both grid-facing and microgrid-facing functions. In addition to UTK, we have several team partners. EPB and Southern are our utility partner. They provide guidance on system requirement for PCS. EPC Power is our partner for PCS hardware. As I mentioned, the project has been going on for 3 years. This year, BP5, the main tasks are two. One is on converter, the other is on control. For converter, we focus on the three-phase distribution grid side, the AC/DC PCS converter design and build. Then we will test the full back-to-back PCS module at rated power and rated voltage, including grid support functions and scalability. Specifically, we have completed three-phase microgrid-side PCS converter testing, which was a subtask in BP4, delayed until this year. We also have finished grid-side PCS converter design late last year. We are in the process of testing and building the full AC/DC AC back-to-back PCS converter module. Also, the scalability demonstration is also in the process. On the control, we have developed both hardware and software. Will be implemented in the full back-to-back PCS module. The hardware development was done already. The testing is in the progress. Now I will talk about some detailed accomplishment in BP5. The first one is testing of the microgrid-side PCS that was built in BP4. Originally, we were not able to achieve full voltage due to some noise issue with gate drive protection. And in BP5, we successfully resolved that. As a result, we were able to test the converter at full voltage and full power rating, and it shows the voltage and the current waveform. On the distribution side, the PCS converter design, we have finished that design, considered grid impact, and I already mentioned we improved the gate drive design with better noise immunity. So we already have built many components and subsystems. This shows one of submodules, the new gate drive, the gate drive power supply, current sensor, voltage sensor, and also the arm inductors. Also, we have adopted new packaged 10 kV MOSFET because the earlier ones were from Wolfspeed. We no longer have enough. so we have to package some new ones from the warp speed die by PowerX. So far, we have 2 of these MOSFET pass continuous switching test at 7 kV. The rest have also been acquired and shipped to us. They have actually better partial discharge performance than the previous devices. So we are in the process of the building and testing in order to have the full voltage back-to-back PCS converter testing. We need to have a medium voltage transformer, so we have acquired one. I already showed different components being built in previous pages, and this one shows their placement within the cabinet. So we have 3 cabinets for 3 phase lags for the grid-side PCS. This shows the enhanced noise immunity submodule, mainly on the gate drive side and the power supply side improvement. When we were able to improve that, reduce false triggering due to the noise, we have fully qualified the submodules for the distribution grid side in a single phase lag testing at 25 kV DC link, which is the rated DC link voltage. So we are ready to build the rest of the submodules and phase lags for the whole converter. On the controller, this left-hand side shows the overall architecture of the full PCS, back-to-back PCS converter. It has a central controller, phase controller, as well as individual converter submodule controller. The right-hand side shows the hardware. This page shows some preliminary testing for the grid-side PCS control in rectifier mode. As we know, in normal conditions, the grid-side converter will run in rectifier mode. The microgrid-side will be running in inverter mode. So this shows the whole process of the pre-charge as well as establishing the full voltage and some current. At this point, we are still running at low voltage and small power because the medium voltage transformer has not been set up yet. Later on, this will be increased to higher voltage, rated voltage, and rated power. So with that, I'd like to summarize the accomplishment and outcome, mainly in BP5 of this project. First, we have successfully tested the microgrid-side PCS built in BP4 at rated DC AC voltage and power. And the grid-side PCS has been designed, some module tested with enhanced noise immunity. The back-to-back PCS controller hardware has been developed. The back-to-back PCS converter building and testing is in progress. During the project, we have published 3 journal papers and 14 conference papers. We have involved 9 students on our project. So in future, we will be completing the back-to-back PCS building and testing for the rated power, rated voltage, as well as its grid support functions. We also will demonstrate the PCS module scalability in testing. With that, I would like to thank Power America, our partners, as well as NSF and DOE through Current. Thank you.